Hey everybody, this is my solving one variable equations and inequalities workshop. Glad you all could join me. I'm kind of a big deal on YouTube now that I have people actually searching for my videos and finding them. And yes, there will be merch coming for all you squiggle buddies out there, whatever you want to call yourselves.
Ka-chow.
Ka-chow, sure. Anyway, so we're going to talk about solving one variable equations, and there's a couple of things that we sort of need to talk about in terms of the particular focus area that you're all working on. When you find a solution that fits into questions that will ask you, like, what can you say about this particular equation? Basically, they're asking you to find a solution or solving it. What are the solutions? Solve the equation. So that's what we're going to be working on. So we're going to start off with something really simple. This particular equation is one of the easiest ones on the entire thing, but I think it's a good one to take a look at because the solutions seem to be throwing some people off. So when we look at solving equations, there's a few steps that we kind of want to make sure that we do first. Number one, we want to simplify both sides of the equation first. And what I mean by that is deal with parentheses or combining like terms. So if I take a look at this first equation here, I don't have any parentheses that I need to deal with, and I don't have any like terms. So this first step, already done. The next thing that we want to do is we want to eliminate terms from either side to isolate the variable. So I want my x to be alone eventually. My goal is to get x equals a number. Now, in order to do that, here on the left side we have 2x, but I also have this extra piece, this 5. So I need to eliminate this 5 first. 5 minus 5 cancels, and I have 2x equals, well, 5 minus 5, I've noticed that some people look at that and they say, oh, well, it cancels on both sides. What do I do? Is there no solutions? No, that's not true. 5 minus 5 is just 0. I just don't write it over here because I don't need to. But on the right side of my equation, what I have left after I subtract 5 is just 0. Now, the next thing that we're going to want to do is solve for our variable. So I've isolated my x term. Now I want to get just one x by itself. Now, when you have a number next to a letter, that always implies multiplication, and the way we undo multiplication is division. 2 divided by 2 is 1x equals 0 divided by 2 is just 0. So the solution to this equation right here is x equals 0. So the next equation that we're going to take a look at is a little bit more complicated. 15 minus x equals 2 times x plus 3. So again, number one, simplify both sides, which means I got to deal with my parentheses and combine like terms. Looking at the left side, I don't have any parentheses and I don't have any like terms, so I'm done over there. On the right side, I do have parentheses, so what I need to do then is get rid of them. Now, normally with order of operations, we say you do what's inside the parentheses first, but x and 3 are not like terms, so we can't actually do anything with that. So I'm going to skip that step by using the distributive property. Because what's happening here is we have 2 times everything inside the parentheses, so I'm going to take 2 times x and 2 times 3. All right. No like terms to combine. I've dealt with my parentheses. This is as simple as it's going to get. Next thing I need to do is start eliminating terms from either side to eliminate the variable, to isolate the variable. I usually like having my x values on the left side, so I'm going to eliminate the x's from the right. 2x minus 2x cancels, and I get 15 negative x minus 2 more x's. So I have negative 1x minus 2 more would be negative 3x's equals 6. Then I need to get this term by itself, so I'm going to subtract 15. And I get negative 3x equals negative 9. divide by -3, divide by -3, we get x equals 3. So that one's not too bad. I got two more real quick, because we're going to find some weird situations occasionally when we go to solve these. 7x plus 5. Well, first of all, just looking at this right now, there isn't a single number in the entire universe that you can multiply by -7 and then add 3 or 5 and get the exact same number. So just looking at this, it looks like there's no solutions, but it'll become really obvious once we start trying to solve this thing too. So the first thing I want to do, parentheses, no. Combine like terms, no. That's already done. So eliminate terms from either side. I like having my x's over on the right side, so I'm going to eliminate the x's left side. So I'm going to eliminate from the right by adding 7x to both sides. Well, 7x and 7x cancel. I just get 3. Negative 7x and 7x cancel, and I get 5. Now, you might be thinking, huh, that's weird. 3 is not equal to 5. You're right, it's not. What this right here indicates, this never true statement tells us that there are no solutions. So 3 equals 5 is never true, therefore, that's what the 3 little dots mean, no solutions. Now there's one more equation here that we can take a look at. 6x plus 12 equals 12 plus 6x. If I start to do the same thing that I did before, subtract 6x from both sides, those eliminate, and I get 12 equals 12. This is always true. Now, if you end up with a statement that is always true, there are infinitely many solutions. Which is just a fancy way of saying that x can be anything. 6 times any number plus 12 is going to give you the exact same result as 12 plus 6 times any number. The order doesn't really matter. It always comes out the same on both sides, no matter what x is. So that's solving inequalities, or equations. The next thing that we need to talk about is solving inequalities. Now, solving inequalities is exactly the same as solving equations, except for one thing. When we get to the step where we multiply or divide at the end, if we're multiplying or dividing by a negative, we have to change the direction of our inequality sign. That's the only difference. Otherwise, we're going to use the exact same steps. So the first one that I'm going to take a look at is 2 times the quantity x minus 2 is less than x plus 2. Well, my first step is I want to simplify. I see parentheses, so I'm going to use the distributive property. And I get 2x minus 4 is less than x plus 2. Next, I want to eliminate terms from either side to isolate the variable. I'm going to get rid of the x over here on the right because I like my x's on the left side. Those cancel. 2x minus 1x is just 1x. And then you still have this negative 4 here. So x minus 4 is less than 2. And then all I got to do is add 4 to both sides. And I get x is less than 6. Now, I didn't multiply or divide by negative on that problem, so I don't have to worry about any extra steps. Now, the last thing for an inequality, I would add step 4 for inequalities only. And that's graph your solution set. We talked about this yesterday. The thing with inequalities is that you don't have one number that's a solution like you would with an equation. You have a whole bunch of numbers. So we have a set of numbers that are a solution. So we're saying that x is less than 6, which means that it can be anything as long as it's smaller than 6. The way that I like to graph these is I'll just do a number line with 0 and the number that I'm looking at. Then I have to look at what kind of an inequality is this. It's not an or equal to, so 6 would not be included in this. 6 is not less than 6. So to show that, I'm going to put an open circle on the 6. And then I have numbers that are less than 6, so those are numbers that go to the left from there. So you can do a little squiggle line, or you can just do a really dark line, or some people even just go like up and point to the left. Either way, it doesn't really matter. Let's take a look at a couple more. Let's say we got negative 3 times 2y plus 4 is less than or equal to 12 minus 4y. So step 1, simplify both sides. I've got parentheses, so I'm going to distribute. Negative 3 times 2, negative 6y. Negative 3 times 4, negative 12. Less than or equal to 12 minus 4y. I'm going to eliminate terms from either side. Again, I usually like having my variable on the left side, so I'm going to eliminate the y's from the right. And you know what? I can also go ahead and get rid of this negative 12 all at the same time. So negative 6 plus 4 is negative 2y's is less than or equal to 12 plus 12, which is 24. Now I need to divide by negative 2. So y, and this is where we find the difference between equations and inequalities. With an inequality, both sides are exactly the same. There's no directional aspect to an equal sign. But when you're dealing with an inequality, there is. We just divided by a negative, so I need to flip around my inequality sign. So instead of saying that 24, the right side is bigger, I'm going to say that y is greater than or equal to negative 12. Now the reason why that happens is because if you look at a number line, 1 is definitely less than 2. But if I multiply both sides by a negative 1, what happens is those values kind of get flipped to the other side of the number line, and negative 1 is not less than negative 2 anymore. Negative 2 has a bigger quantity, but since we're dealing with negatives, negatives with a bigger quantity are further to the left, so they're actually smaller. So the relationship between them changes when we flip it across the number line, okay? Numbers that are further to the right end up further to the left when you multiply by a negative, so you got to swap that sign. Now the way we would graph this again, I would just do a number line with 0 and negative 12 on it. Greater than or equal, so negative 12 would actually be a solution to this because negative 12 is greater than or equal to negative 12. And then numbers that are greater than negative 12 would be to the right. So that would be your answer and the graph for your solution set. So just to wrap things up, solving equations, it's these first 3 steps here basically. Simplify both sides, then you want to eliminate terms from either side to isolate the variable, and then solve for x by multiplying or dividing. With an inequality, there is this extra step where you do graph your solution set, and also the one major big difference is that anytime you multiply both sides of an inequality or divide both sides of an inequality by a negative, you need to flip your sign around. That should be everything that you need to know in order to solve equations and inequalities. Squiggle out, my dudes, and buy some merch.
Yeah.
Like, comment, subscribe, click that notification bell. Oh, anything else that I need to add? Ka-chow.
Live long and prosper.
Live long and prosper.